All right, so this is 8.4 valence electrons. I'm sure you've come across valence electrons already in your junior science classes. At least most of you have. So before in the junior science classes, you probably just did the representative elements in your S and your P blocks. Those are pretty simple. If you look at just looking on the periodic table, so group 1, they're going to have 1. Group 2, they're going to have 2. If you jump over to the boron group, group 13, right? Group 13 has 3, group 14 has 4, 15, 5, 16, 6, 17, 7, and your 18, your noble gases, they have 8. Some textbooks say they have 0, some say they have 8. I'll accept 0 or 8 from neon all the way down, right? Helium has 2 or 0 for it. All right, so that's how you do it before. Sometimes again, it's a little more tricky if you have the valence electrons in the your valence electrons in the transition metals, or for ions also get a little bit tricky too. So valence electrons, electrons that take part in chemical reactions, we can lose or gain valence electrons if you got an ion, or valence electrons can be used to bond with each other to make with other atoms to make a compound. So they're the reactive electrons. So valence electrons, here's our textbook definition. Valence electrons are all the electrons that are not in the core, right? So exclude the ones in the core and not in filled d or f orbitals. All right, so if d or f are filled, we don't count them. We count all the s's and the p's. All right, so aluminum, right? You've done this one before. You can look on the periodic table. Okay, group 13, there's 3. If we want to do it the core notation way, right? So you look at it. So it's got neon core, 3s2, 3p1, right? 2 plus 1 is 3. So we got 3 valence electrons. All right. Same for Ga, our gallium, right? 4s2, 3d10, 4p1, right? Exclude D because it's D10. D10's full. So 2 plus 1 is 3. All right. And you can look on your periodic table. Okay, gallium, it's in group 13. So it's got 3. All right, lead. A little bit more difficult, but we can look at it on the periodic table. Do the full core notation for this one. So it's got, what is it? Group 6. So it's got xenon core, 6s2, 4f14, 5d10, 6p2. All right. D and F are both full. So 2 plus 2 equals 4. And you can see it's also in group 14, the carbon group. So 14, it's also, you can also see it's got 4 there. Okay, so xenon. All right, so core notation for xenon, we have to go back. Krypton core, 5s2, 4d10, 5p6. D's go. So 2 plus 6 is 8. But the definition for some is the valence electrons are ones that take part in chemical reaction. And since they're non-reactive, are by definition could be 0, or our other definition 8, because we're taking out the S, we're adding the S's and the P's together. So 0 or 8 is fine for the answer for valence electrons for all noble gases. All right, whatever you want to do. All right, let's do manganese. All right, so senior periodic table, 4th energy level, do the core notation for it, 4s2, 3d5. All right, so we got 2 plus 5 is 7. So we got 7 valence electrons for our Mn. All right, silver. There it is in the 5th period. All right, so the full notation for this is krypton core, 5s2, 3d9, but we realize that this is one of our exceptions. All right, that where we have D9. Anytime we got D9 or D4, we're taking 1 from the S. So S is going to give 1 to the D's. So it should be 4d9, not 3d9. Here, I'll change that real quick. All right, sorry about that. All right, 49. All right, 5s2, 4d9. All right, so we're taking 1 from the S's and putting it to D's. So that's going to be 5s2, 4d10. And so we can see D's now full. So we're going to have 1 valence electron. All right, so our answer for, our homework for this is assignment 8.4. All right, it's page 158. number 29. All right.